everyone, it's Mrs. Martello. We're going to look at section 4.2 and I am on page 182 if you want to follow along. In this section we're going to learn about a new form and we're writing equations of lines in point-slope form. So I wrote this down on my paper. I would suggest that you write this down as well if you want to pause the video and copy it down. Point-slope form is an equation of the form y minus y1 equals m times the quantity, so that's what this parentheses are here, times the quantity of x minus x1. So in this equation, you should first right away notice the m is here. Our m is still the slope, nothing changes about that. And in this formula, we have an x1 and a y1. That's going to be our given point that they give to us. In this form, x and y stay variables. x1, y1 are the numbers from the given point. X and y stay as x and y. So let's take a look at example 1. In example 1 here, we have write an equation in point-slope form of a line that passes through the point -8, 3 and has the slope of 1/4. So again, here's our point-slope form, y minus y1 equals m times x minus x1. So our point that they're giving us here, this given point, remember this is x1 and y1. Let's plug that all into our equation. We're going to keep y as y minus the y1 is 3 equals our m is our slope, which is 1/4, times the quantity, so they used a bracket here, but you can use parentheses, that's fine, of x minus x1, which is -8. So here, instead of leaving it as minus a -8, they simplified this as much as they could to make it be +8. And then you leave your answer just like this. This is slope-intercept form. You don't do anything to this equation. You want it to look like y minus y1 equals m times the quantity of x minus x1. And that is point-slope form. Let's do another one like this. We're going to go down here and we're going to do monitoring progress number 2 together. I'm going to write down my information here. I have the given point is 4, 0, and our m is -2/3. Okay, remember that in this form, the given point is x1 and y1. We're going to plug it into point-slope form, which is y minus y1 equals m times the quantity of x minus x1. Let's plug our numbers in. We're going to keep y as y minus my y1 is 0 equals m, which is -2/3, times the quantity of x minus x1 is 4. Now again, I want to simplify as much as I can here. On the left side, anything minus 0 just simplifies to whatever that is. So y minus 0 would just be y equals -2/3 times the quantity of x minus 4. And that is our equation in point-slope form. Okay, let's go to the next page. We're going to look at writing the equation of the line given 2 points. So the first thing that we need to do if we're given 2 points is we have to find the slope. Remember, we're going to use the slope formula to find the slope, which is y2 minus y1 over x2 minus x1. Then we're going to use the slope and one of the points to write an equation of the line in point-slope form. So let's take a look at example 2. In this example, write an equation in slope-intercept form of the line shown. So notice how the result, they want it in slope-intercept form, but we're going to use point-slope form first and then turn it into slope-intercept form. I'm going to do this one with you. So for example 2, let's write down the points from the information in the graph here. Our first point is 1, 2, and our second point is 3, -2. Our first step is let's find the slope. So remember, our slope formula is y2 minus y1 over x2 minus x1. In our 2 points, we have x1, y1, x2, y2. Let's plug that in and let's find the slope. So we're going to have -2 minus 2 over 3 minus 1. In the numerator, we get -4. In the denominator, we get 2. Simplify, we get -2 for our slope. Then we're going to pick one of these points, and it doesn't matter which point you pick. I'm going to pick the first point just because it's easier for me to look at that first point. And now we're going to plug this into point slope form. Y minus y1 equals m times the quantity of x minus x1. Let's plug it in. We're going to keep y as y minus y1 is 2 equals m, which is -2, times the quantity of x minus my x1 is 1. Now this would be our equation in point slope form. If they asked us to write an equation in point slope form, we would be done. But go back to the directions, notice how they said we want slope intercept form. So what that means is now let's turn this equation into y equals mx plus b. So let's solve this equation for y. All right, we're gonna solve for y. When I solve for y, my y is on this side. Look at my right side. The first thing I need to do is I'm going to distribute this -2. So first let's distribute and then we'll isolate the y. We're gonna get y minus 2 equals -2x, and this is a -2 times -1, which would be +2. Almost there. Let's solve for y. I'm going to get rid of this -2 by adding 2 to both sides. Line it up underneath its like term, which is the other constant. And let's write our equation. Y equals -2x plus 4. And that would be our equation. I just want to show you, let's double check to make sure that this equation actually goes along with this graph that they gave us up here. Let's see, does this line in fact have a slope of -2? Let's see, on here I would go down 2, right 1. Yeah, down 2, right 1. So it does. Let's look at the y-intercept. Would it be up at 4? So from this point, instead of going down 2, right 1, let's go up 2 and left 1. And yep, that would be up here at 4. So I can just imagine where it is up here. All right, let's do another example like this. We're gonna do monitoring progress number 4. Let's write down the 2 points for monitoring progress 4. We have -4, -1, and 8, -4. So our first step is let's find the slope. So we're going to use our slope formula, y2 minus y1. So -4 minus -1, or I can write +1 over x2 minus x1, which would be 8 minus -4, or I could say +4. Let's simplify. -4 plus 1 is -3. 8 plus 4 is 12. Let's simplify this fraction, and I'm going to get -1/4. There's my slope. Okay, my next step is now I'm going to pick one of the points, and let's plug it into point slope form. Doesn't matter which point I pick, but I'm going to pick the first point just to keep it easier. This is x1 and y1. Let's plug it into point slope form. I like to write down the form. It helps me make sure that I plug the numbers in correctly. Here we go. We want to keep y minus y1 is -1, or I could say +1, equals my m is -1/4 times the quantity of x minus x1 is -4, or I can say again +4. Let's simplify this. Y plus 1 equals -1/4 times the quantity of x plus 4. So if you wanted to, you could just go straight in and write it with these pluses. You don't have to do minus and negative and then fix it. You could just say +1 and +4. Okay, we're not done yet though. This question, the direction says to write it in slope-intercept form. So now let's solve this equation for y. I'm going to take this slope, this negative 1/4, let's distribute it into this parentheses. Y plus 1 equals negative 1/4x. Now negative 1/4 times positive 4 would be a negative 1. We're almost there. Let's solve for y. Let's subtract 1 from both sides, and I get y equals negative 1/4 x minus 2. And that would be our equation in slope-intercept form. Okay, we're going to next take a look here at example 3. Okay, in example 3, now it says we're going to write a linear function f with the values f of 4 equals negative 2 and f of 8 equals 4. So just keep in mind, remember that function notation is f of x. Remember, f of x is the same thing as y. So the number in the parentheses with the f, that's the x coordinate of the ordered pair, and the thing it's equal to is the y coordinate of the ordered pair. So let's keep reading through this example. This first function notation, f of 4 equals negative 2. The x is 4 and the y is negative 2. There's our first point for negative 2. And then our second function notation, f of 8 equals 4. The x is 8 and the y is 4. That's our second ordered pair, 8, 4. Now we're going to do the same exact steps that we just did. Let's find the slope using the slope formula. We're going to do y2 minus y1 over x2 minus x1. So it's going to be 4 minus negative 2 over 8 minus 4. 4 plus 2 is 6 over 8 minus 4 is 4. You can leave it as a decimal, 1.4. Me personally, I would probably have written my answer as 3 over 2. I like improper fractions. Now we're going to pick one of the points, and it doesn't matter which point you pick. This book picked the point 8, 4, which happens to be the second point. And actually, I like that they picked that second point because both of these are positive numbers. Whereas in this one, we have a negative, and negatives kind of get annoying with the minuses in the formula. So I like that they picked this point 8, 4. Let's plug that in. We want y minus y1. The y of this point is 4, so y minus 4 equals our m, which is 1.5, or you could use 3 over 2, times the quantity of x minus x1. Our x of this point was 8. Now we're going to simplify. Let's distribute this 1.5 to the parentheses. Y minus 4 equals 1.5x minus 12. And then finally, we're going to add 4 to both sides here. So we get y equals 1.5x minus 8. So then the function, if you want to write it in function notation, you can use f of x or you can use y. Remember, f of x is the same thing as y. Doesn't matter which one you use. Equals 1.5x minus 8. Let's do another one like this just to make sure that we got it. We're going to take a look at number 5, monitoring progress 5. Let's write these as ordered pairs. G of 2 equals 3. Remember, this is the x and the y. That's the ordered pair, 2, 3. The second function notation, g of 6 equals 5. Remember, this is x and y, so this is the ordered pair, 6, 5. Let's find the slope of this line. M equals y2 minus y1, 5 minus 3, over x2 minus x1, 6 minus 2. I get 2 over 4, which equals 1 over 2. Now let's pick one of the points. It doesn't matter which point we pick. I'm going to pick the first point just because these numbers are smaller, doesn't matter. And let's plug this into point slope form. Y minus y1 equals m times x minus x1. Let's plug it in. Y minus my y1 would be 3 equals my m is 1/2 times x minus x1 is 2. Let's distribute the 1/2. We get y minus 3 equals 1/2 x. 1/2 times negative 2 would be minus 1. Let's solve for y. We're going to add 3 to both sides. Y equals 1/2 x plus 2. Now, that would be our equation in slope-intercept form. I just want to show you something interesting here just to see if you remember what we did back in the previous section, back in section 4.1. So remember in section 4.1, you want to use y equals mx plus b form to get your equation in y equals mx plus b form. So you can do either way. You can use point slope form or you can use slope intercept form, and that's totally up to you. I'm going to show you that you get the same exact answer. So let's do this one for number 5. Your first step would still be to find the slope, doing y2 minus y1 over x2 minus x1, and you would get a slope of 1/2. But now you would plug your numbers into y equals mx plus b, and remember you would solve for b. So remember you're going to plug in m, x, and y, and find b. Okay, let's do that. So I'm going to use the same point. Here's the point. My y is 3 equals my m is 1/2 times x, which is 2, and then plus b. I don't know b. I'm going to solve for b. Let's simplify here. We're going to multiply 3 equals 1 plus b. Now we're going to subtract 1 from both sides, and I get 2 equals b. Now if I write my equation in slope-intercept form, my b is 2, my m is 1/2. Look at that, we get the same exact equation, y equals 1/2 x plus 2. So you can do either way, and it's totally up to you if you want to use point slope form or slope-intercept form, and it's just a matter of preference. Okay, we're going to take a look at one more example here. We're going to look at from the 4.2 exercises. We're going to look at a word problem, number 33. So in case if you want to follow along, I am in the textbook on page 186, and again we're looking at number 33. It says here, you are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers, and then $80 for each additional 1,000 stickers. Write an equation that represents the total cost in dollars of the stickers as a function of the number in thousands of stickers ordered. So let's use this information and let's think about what we are given here in this word problem. We're going to take some notes first and then we'll do the problem. In a word problem, you want to think about what information are you given. The first thing you want to look for is if they're giving you the slope. Remember, our slope in a word problem stands for a rate of change. So again, we want to look for that rate. If it says per or each or every, that's going to stand for a rate in our problem. The next thing we want to look for is if they're giving us a point. Remember, our point is going to be x1 and y1. Now, when they give us a point, what they're giving us is they're giving us a value after some time has passed. So not at the beginning, not the initial amount, but they're going to give us an amount after the beginning. Okay, so this is an amount after some time has passed. Okay, and you'll see what I mean in a minute when we look at this word problem. Okay, let's go back to the problem and let's see if we can identify what are we given in this problem here. In this problem, it says a company charges $225 for the first 1,000 stickers. And then they charge $80 for each 1,000 stickers after that. Well, right away, this $80 for me stands out because it says $80 for each. That's going to be our slope. That's going to be our rate of change. So we're going to write that down as our rate of change here, that our slope is 80. Then let's go back to this information. It costs us $225 for the first 1,000 stickers. That's going to be our ordered pair. That's a point. So we didn't know how much it cost before we bought any stickers. That would be the initial amount. I know how much it costs for 1,000 stickers. So after some stickers have been bought, I know how much it costs. Be careful here. Remember what stands for X and Y. So let's think about this carefully here. Remember that X is the independent variable, and that the Y is the dependent variable. So think about this carefully. Which one of these is the dependent and independent variable? Which one depends on the other? Well, the amount of money you pay depends on how many stickers you buy. So the stickers are the independent variables. Our stickers are the independent. We decide how many stickers we want to buy. But the cost, that's the dependent variable, because the cost depends on how many stickers we bought. So now we're ready to write this as our point. Remember that it says in thousands of stickers. So if it's 1,000 stickers, we're going to use 1 for our X. And then the cost is $225. Okay, let's write our equation. We're going to do point slope form and then slope intercept form. Okay, let's plug it in. We have y minus our y1 is 225 equals m is 80 times x minus x1 is 1. Let's simplify this equation. We're going to distribute y minus 225 equals 80x minus 80. And now let's solve for y. So I'm going to add 225 to both sides. Our equation would be y equals 80x. And if you need to, you can use your calculator. It's totally fine to use your calculator here. Negative 80 plus 225 would be 145. Plus 145. Okay, that's our answer for part A. Let's take a look at part B. Part B says find the total cost of 9,000 stickers. So think carefully about what are they giving us here. The amount of stickers we just said is X, and don't forget that it's in thousands. So for part B, they're telling us that X equals 9. Remember, it's already in thousands when we plug it in. So let's take 9 and let's plug it into this equation. Let's find the cost. Y equals 80 times 9 plus 145. This would be y equals 720 plus 145. So our total cost here is going to be $865. And those would be our answers for this question.